Alright, hi everyone. So this is a video for the geometric sequences in series mixed practice for you to use in reference since I'm not here today. The first problem here says that they give you the first few terms of the geometric sequence, and you need to find the next two terms as well as finding the common ratio. Remember that a geometric sequence works by multiplying by a common ratio, or the same number every single time. So in order to find the next two terms, we need to figure out what the common ratio is. And my suggestion to figure out what the common ratio is, again, that's what you multiply by to get from term to term, is to take this second term, 135, and divide it by the first term of 405. Okay, that's going to tell you what you multiplied by. So if I take 135 divided by 405, it gives me 0.3 repeating, which is the fraction 1/3. Okay, so that looks like my common ratio is 1/3 here. And you can always double check to make sure that you have the right common ratio by checking the next two numbers. If I took 45 divided by 135, I should get the same thing. Okay, so let's see. Yep, I get 0.3 repeating again, so I know that 1/3 is my common ratio. So since I know that 1/3 is the common ratio, to find the next two terms, I would take 45 times 1/3. So let's do that. Let's do 45 times 1/3. That gives me 15 as the next term. And then again, 15 times 1/3 will give you 5. So these are your next two terms of the sequence. We're going to do the same thing in B and C. Find the common ratio by figuring out what is 108 divided by the first term of 81. So 108 divided by 81 gives you 1.3 repeating, and that's 4/3. But if you don't know that, hit math, enter, enter. It'll tell you that the common ratio there is 4/3. So 4/3 here. All right, now to find the next two terms, the next one you find by taking 144 times 4/3. So we'll do 144 times 4/3, which gives you 192. And then to find the next term, you take 192 times 4/3, which is 256. All right, now that you've seen a couple, I want you to pause the video, try the third one on your own, and then come back and see if you have the right answer. So go ahead and hit pause. All right, now if you need to see this one worked out, again, to find the common ratio, you take the second number, the 3, divided by the first term. Well, 3 divided by -1 is -3. That is your common ratio. And you can see that if I took 3 times -3, I get to -9, times -3 is +27. So to find the next two terms, I take the last term, 27, and I'm going to multiply it by our common ratio of -3, which gives me -81. Remember that when you have a common ratio that's negative, the signs alternate. So we have a negative, a positive, a negative, a positive. All right, I take -81 times -3 should give me a positive 243. All right, that is number 1 for you. Number 2 is pretty simple. We are just going to be writing the equation for the nth term of this geometric sequence. Now, when I'm writing an equation for the nth term, I'm not solving anything. I should still have n in my answer. I just want to write an equation for a sequence. So I'm using the a sub n formula here, just to write out what I would use to find another term in the pattern. So when I write this equation, I need to know a couple of things. I need to know what a sub 1 is. A sub 1 is the first term. So my first term here is 36. Then in parentheses goes my r, my common ratio. And we can find the common ratio the same way that we did up above. 21 divided by 36. That's going to give me my common ratio. So if I go back to my calculator and do 21 divided by 36, I get a weird looking decimal. Let's turn that into a fraction here. And we see that the ratio is 7/12. So since 7/12 is my common ratio, that goes in the parentheses here. And then the formula is finished by adding the exponent n minus 1. That's the equation you would use to find any other term or the nth term of our sequence. We're going to do the same thing for b here. I know that -2 is my first term. So when I write my equation, I'm going to start it with -2. I need to find the common ratio. So since my sign is alternating negative to positive to negative, I know my common ratio is going to be negative. I'm going to take the second term divided by the first term, which is -5. So -5 goes in my parentheses, and then I have the exponent of n minus 1. That's all there is to number 2. All right, number 3 says, find the indicated term of each geometric sequence. So when you're finding a term of a sequence, you're going to use the sequence formula. Okay. So in order to find this term, we need to fill in what we know into the formula that I circled up there. Okay. I know that n is 8. That 8 means that I know what's going to go in for the subscript of a here. So I'm trying to find the 8th term, a sub 8. I know that a sub 1 is 1/3, so I'm going to put that in there, times my common ratio of 3. Now again, n is 8, so I'm going to put 8 minus 1 as my exponent, and I'm going to simply type that expression into my calculator. So you'll come to your calculator, you'll make the fraction 1/3 times 3 to the 8 minus 1 power. Okay? And you get 729. Now what again that tells you is that if you listed out 8 terms of this pattern, so if you did 1, 2, 3, 4, all the way up to term 8, you would start at 1/3, multiply by 3 and get 1, then 3, then 9, all the way up until you get to the 9th term, or the 8th term, I'm sorry, which is 729. Okay, that's what you're finding here. All right, I want you to try B on your own. Go ahead and hit pause, and then come back, and you can check your work. All right, for B, we're doing the same thing. We are finding the 8th term again, so we're finding a sub 8. We know the first term is 4,096, and our common ratio is 1/4. Since I'm finding the 8th term, I put 8 in for n, and I'm going to go ahead and type that into my calculator. So I have 4,096 times 1/4, and your exponent again is 8 minus 1. I get 0.25, which is 1/4. I don't care if you leave that as a decimal or as a fraction. Either one is fine. So that is the 8th term of that pattern. It is decreasing because the common ratio is less than 1. All right, we started off pretty easy. Now let's jump to number 4, which finds you the sum of each geometric series. Now a geometric series, I'm going to scoot this down a little to put our formulas up here. A geometric series is when you are adding up all the terms of a sequence. So we're going to use the S sub n formula to find the sum of the series. So here we have to identify a little bit of information. I'm given that the series is 7 plus 21 plus 63, and we're adding up all the terms until the 10th term in the pattern. Well, in order to use this S sub n formula, I need to know the first term, which here is 7. I need to know n, which is 10 here, because I'm trying to find the sum up to 10 terms, and I need to find the common ratio. As per the other 3 problems, to find the common ratio, I take the second number divided by the first number. Well, 21 divided by 7 is 3, so our common ratio is 3. Okay, so now I take all those 3 pieces of information and I'm going to put them into that formula. So again, I'm trying to find the sum of 10 terms here. Well, I start with a sub 1, which is 7. Now in parentheses, I'm going to take 1 minus my common ratio of 3, and I'm going to raise 3 to the 10th power. The denominator is 1 minus my common ratio again. All right, so now all you have to do is carefully type that exact expression into your calculator. So I like to make this right into a fraction here, if you have that ability on your calculator. 7 parentheses, 1 minus 3 to the 10th, and make sure you bring your parentheses down so it encloses the entire numerator. And then the denominator is 1 minus 3. All right, and you should get that same answer, 206,668. So if I add it up, this pattern, 7, 21, 63, on and on and on, for 10 terms, I would get that value. All right, let's do the same thing for B. Again, if you want, hit pause, then come back and check your answer here. All right, so my first term, let's list out all the information we know again. The first term is 4,096. My term number that I'm adding up to is 15. And the common ratio here, let's figure it out. Negative 512 over 4,096. Let's figure that out. Let's type it in. Negative 512 divided by 4,096 gives me negative 0.125. Now, if you want to use the decimal, that's totally fine. Oops. Or you can convert that into a fraction, which is negative 1/8. Either one is fine. It really doesn't matter which form you use. I think I'm going to use the decimal form here for now. Okay, so negative 0.125, or again, that's negative 1/8. All right, so let me put this into the sum formula. Hold on, I'll move the screen up a minute. So when I do my sum here, I'm finding the sum of 15 terms. All right, I put in the first term, 4,096. Now here I want you to be really careful with what you put in your parentheses. 1 minus. Since my common ratio is negative, I'm going to put it in parentheses. Negative 0.125 to the 15th power. Make sure you put the common ratio in parentheses, especially if it's negative. Divided by 1 minus negative 0.125. All right, let's very carefully type that into our calculators. Again, start with a fraction if you have that ability. 4,096 times 1 minus, here's our set of parentheses for the negative. 0.125, close the parentheses and then raise it to the 15th power. All right, then on the denominator, we'll do 1 minus negative 0.125. And that is the answer you get. Okay, that is correct. Let's see, let me scroll down a little here. It says in the direction to round to the nearest thousandth, which is 3 decimal places. So we'll write the answer as 3,640.889. All right, so hopefully you've been okay with those problems so far. Let's scoot over to number 5. A and B are very similar. We did the same thing here with arithmetic sequences. But this time we have to find the missing terms of a geometric sequence. So here's how I like to do this. I really like these problems. I'm going to figure out what the common ratio is first. So I need to say, okay, if I start with 2, I have to multiply 2 by the common ratio 1, 2, 3 times. Which means I multiply 2 by r cubed, the common ratio 3 times, to get to 54. Now all you have to do is simplify that expression for r, and then you know your common ratio, and you can fill in your blanks. So I'll divide both sides by 2, and get that r cubed equals 27. Now to find the common ratio, I just take the cubed root of both sides, and r equals 3. That's your common ratio. So now you fill in the blanks. 2 times 3 is 6. 6 times 3 is 18, and you can double check, if you need to, that 18 times 3 is 54. That's exactly what we wanted. Now, I multiply to go to the right. If I have to go backwards to fill in those spots, I have to divide. So I have to take here to go backwards. I have to divide 2 by 3, and that's 2/3. To go backwards one more time, I have to divide 2/3 by 3. So I'm going to take 2/3 divided by 3, and that is 2/9. There you go, you found your first sequence. So I want you to hit pause. I want you to try part B. If you need to, come back and I'll walk you through it. All right, same kind of problem here. I start with 6, and I have to multiply 6 by the common ratio, looks like 3 times, to get to negative 48. All right, I divide by 6. That gives me r cubed equals negative 8. And the cubed root of negative 8 is negative 2. So I know that my common ratio is negative 2, which means to fill in these blanks, I have to take 6 times negative 2, which is negative 12. Negative 12 times negative 2 is positive 24. And that works out because positive 24 times negative 2 is negative 48. To go backwards, I have to divide by our common ratio of negative 2, which is negative 3. All right, go ahead and flip your page over. We're on number 6 now. We are given a sequence, 3, negative 6, 12, negative 24. And I want to decide if this is arithmetic or geometric. Well, remember, arithmetic means that you add or subtract the same term every time. And geometric sequence means you multiply by the same value every time. And it looks like to get from 3 to 6, or negative 6, I'm sorry, and negative 6 to 12, I'm going to be multiplying by negative 2. So this is a geometric sequence. And again, because you multiply by negative 2, excuse me, every time in order to get the next term. Now, we did this before. In part B, it says write a formula for the nth term of the sequence. So when you're writing a formula for the nth term, you need to use the nth term formula, a sub n. So in general, our formula is going to be a sub n equals. I need to know the first term, that's a sub 1, which is 3, times the common ratio. We said we're multiplying by negative 2. And the formula finishes with an n minus 1. Now it says find the 19th term of the sequence. So you're going to take that same formula and put 19 in for n, a sub 19. Well, you're going to have 3 times negative 2 to the 19 minus 1 power. So when you type that in your calculator, I'll just tell you the answer here. You can type it in yourself. 786, 432. That would be the 19th number in this pattern. Now it says, I know the 19th number. What if I added up every single number in this pattern? Well, when they tell you to add up the numbers of a sequence, you're using the series formula. So we're going to find the sum of 19 terms. Now for this, I need the first term, which again is 3. Then in your parentheses, you're going to do 1 minus. Now our common ratio is negative 2, so I'm going to put my common ratio in parentheses to the nth power, which is 19. And that all goes over 1 minus negative 2. Now you need to be really careful when you type this into your calculator. All right, again, start with a fraction. And we have 3 times 1 minus. You put your ratio, your negative ratio in parentheses, and then raise it to the 19th power. Then your denominator is 1 minus your common ratio. Right? That's the right value, 524, 289. But then it says, what do you notice here? You notice that the sum that we just found is smaller than the 19th term. Why do you think that is? Well, what do we notice about this sequence? It goes positive, negative, positive, negative. And it turns out that the negatives just kind of like subtract off a lot of value from your sequence. So instead of getting as large of a number as you think you're going to, those big negatives start to take away as you add up. All right, number 7. I have a sequence 1, -1, 1, -1, on and on and on. Is this an arithmetic or geometric? Well, it's going to be a geometric again. Because if I find my common ratio, if I take my -1 divided by 1, I get that the common ratio is -1. That's what I'm multiplying by every time. So every term here, you are multiplying by -1. So now that I know my common ratio, I can write an equation for the nth term. And if I'm finding the nth term, or just an equation for the sequence, I use the a sub n formula. Well, my a sub n formula starts with the first term, which here is 1, times the common ratio that I found of -1 to the n minus 1 power. Now it asks us some different questions this time. It says if n, the term number that you're finding, is odd, what's the sum of the first n terms? And then it says what happens if n is even. So let's discover what happens here. So let's take a case. If n is odd, so let's try if n is 5. Okay? So if n is 5, let's put what we have into our sum formula and see what happens. So I would have the sum of 5 terms equals, start with, remember my sum formula is up here, the first term of 1 times 1 minus -1 in parentheses to the 5th power all over 1 minus -1. So if I put that into my calculator, I would have 1 times 1 minus -1 to the 5th over 1 minus -1. We have lots of minuses and -1s here. And it turns out that this sum is 1, positive 1. Right? So let's just write that down for now, and then we will figure out what happens. So it looks like your sum is 1 here. If n is even, I'm going to do the same thing. Let's choose a case. I'm going to let n equal 4. If n is 4, let's find the sum of 4 terms. So I'll have 1 times 1 minus, again, -1 in parentheses, but this time to the 4th power over 1 minus -1. And I'm going to type the whole thing in again, but to save myself some time, I'm going to just get my answer from up here. Oops. There we go. Change that to a 4. Enter. And I get 0. Interesting. Okay. So I get that the sum equals 0. Now let's talk about why. If n is odd, remember your pattern is 1, -1, 1, -1, 1, -1, on and on and on. So if I have an odd number, so that would kind of eliminate this one right here for a minute. If I have an odd number, 1 minus 1 gives me 0. But if I add 1 again, that sum is now up to 1. When I subtract 1 from here, when I get to this term, I get back to 0. And then I add 1 again, and I get to 1. So your sum can either be 0 when you add 2 1s and -1s together. The pairs for even are always going to cancel out to be 0. So when you have an odd term, that doesn't have anything to cancel out with, so it's just positive 1. However, for this even case, it's always 0, again, because those pairs add up to 0 and they cancel each other off. Okay? So just kind of a fun way to look at that one. Okay, let's look at the next one here. Now we have some word problems to finish off. It says a virus goes through a computer infecting files. One file was infected initially, and then the number of files doubles every minute. Okay, so let's start with what we know. One file was infected initially. That means your first term of this pattern is 1. You start with 1. The number of files doubles every minute, which means that your common ratio is 2. That's what you are multiplying by to find the next term. It says how many total files. That means you're going to be finding a sum after 20 minutes. And 20 minutes is your term number, your n. How many times are you doubling? So we need to find S sub 20. Because we're finding a sum here. Whoa, I'm so sorry. I'm going to use the S sub n formula. So for a sub 1, I put in my first term, which we know is 1. 1 minus my common ratio of 2 to the nth power, which is 20, all over 1 minus 2. We're going to type that into our calculator here. 1 times 1 minus 2 to the 20th over 1 minus 2. And that value here that we got on our calculator, this 1,048,575 files, is how many files would have been infected if it doubles every minute for 20 minutes. So from 1 to over 1 million very, very quickly with this pattern. All right, number 9 is multiple choice. Again, as you read through, write down what you know. Iman, that's how I think you're going to say it. Iman starts with $1 on day 1. So that means the first term of your sequence is $1. The money doubles every day. So again, excuse me, your R is 2. On which day? That means I don't know N. They're asking me for what N is here. On what day will she have more than $10,000? So that 10,000 is actually going to be your A sub N. We know that at some point on day 1 she has $1, the second day she has $2, then 4, then 8, then 16, on and on. Eventually she's going to get to 10,000. That's a term in this sequence. It's not asking for a total, just an amount of money. So I need to use my sequence formula over here. So let's put in what we know. A sub n, the first thing here is 10,000. We know A sub 1 is 1, and my common ratio is 2. My exponent is n minus 1. I don't know what n is yet. So I have to start by simplifying this, and normally I would divide by 1 here, and I'll show you that, but you know that dividing anything by 1 doesn't change the value. So you really have 10,000 equals 2 to the n minus 1. Then you have to pull out some information that you have learned previously. How do we get an exponent or a variable out of an exponent? Well, remember last unit we said you have to throw a log at it. The only way to move that n is to take the log of both sides. Now, since I have 10,000 here, I'm going to use the common log of 10,000 equals. Now, remember, when you take the log, that exponent pulls down in front of the log. That's a logarithm log. Okay, now to solve this, I need to move the logarithm first. So I'm going to divide by log of 2, which again, I'm going to leave this fraction like we always did. Don't simplify it until the end. So I have log of 10,000 divided by log of 2 equals n minus 1. To get n by itself, I'm going to then add 1 to both sides. It's going to make log of 10,000 over log of 2 plus 1. So you definitely need your calculator for this. Log of 10,000 divided by log of 2. You're going to hit enter and then add 1. So you get here that n is 14.288. And we just have to match that with a multiple choice answer, which looks like day 14. Oh wait, on which day will she first have more? So it looks like on day 14 she gets to 10,000. So on day 15, I have is the first time where she actually will have more, right? Because it happens during day 14, so day 15 she'll have more than 10,000. All right, great. Let's look at the last problem here, number 10. Jeremy lost his lab notes for AP Bio. He's studying cell growth and conducts an experiment growing bacteria on a petri dish. The only data that he has is that the second observation, A sub 2, is 12 bacteria. So let's write this down. A sub 2 is 12. And the fifth observation is 768. For some reason, I'm not really sure, but Jeremy needs to know how many bacteria there were on the 8th observation. But he lost everything except the second and the fifth observation. So we need to somehow find the 8th observation. Here's my suggestion. I would write this out thinking about blanks here. So I have A sub 2, A sub 3, A sub 4, A sub 5. And I'm going to put my information on my blanks. Now I'm going to set this up similar to what we did in number 5. I need to find the common ratio. So I know if I start with 12, not 12 equals, just 12. Now if I start with 12, I have to multiply by the common ratio 1, 2, 3 times to get me to 768. Now I'm going to solve that for r. So I'm going to divide by 12 and get r cubed equals 64, and then take the cubed root. That gives me a common ratio of 4. So that means that you have to multiply by 4 over and over again to find the number of bacteria. Now there are a couple of ways that you can finish this problem. You could keep writing out blanks here for 6, 7, 8, and just sit here and multiply by 4, by 4, by 4, which is totally fine. So if we did that, we'd have to multiply by the common ratio 1, 2, 3 more times. So I could take my calculator and go 768 times 4, that's 1. That gives you A sub 6. This gives me A sub 7. This gives me A sub 8. That doesn't seem like the right thing. Hold on. 768. Oh, because I multiplied by 3. That would do it. All right, let's start over. 768 times 4. That's the 6th term. That's the 7th term. And this would be the 8th term. So if you want to do it that way, you can get that the 7th term, the number of bacteria cells for the 7th term is 49,152. That's totally fine to do it that way. I'm going to scoot down into the next part here. I'll erase in a minute. However, if you wanted to, you could work backwards. You could use the formula. And you could say, okay, I need to find A sub 1, which is over here. And to go backwards, you would need to take 12 divided by 4, which is 3. So it means that Jeremy starts with 3 bacteria, and then you could use your A sub n formula to find the 8th term. You say, okay, now I know the first term is 3. We're multiplying by 4 every hour. And I need to find the 8th observation. And again, if you typed this into your calculator, you would get the same value. So there are 2 ways to do that problem. I don't care how you do it, as long as you get the right answer. Either option is fine. Now it says let's find the total number of bacteria after 5 observations. So if I add up 3 plus 12, on and on up to 768, how many bacteria did he total have? So the sum here, S sub 5, I need to find the total number of bacteria here. Well, I do know the first term. So see, it did work out. I needed to know the first term here, which is 3 times, in my parentheses, 1 minus my common ratio of 4 to the 5th power divided by 1 minus 4. Let's go ahead and type that into our calculator for the last time. Okay, we'll have 3 bacteria, 1 minus the common ratio of 4 to the 5th over 1 minus 4. And it turns out that after 5 observations, there would be a total of 1,023 bacteria on the petri dish. All right, I hope that makes sense for you. If you have other questions, let me know and we'll work through them together.